put these beginning problems up here just so we can practice using our calculator buttons, because in order to do the formulas, the radical formulas in the applications, you need to use your square root, cube root, and fourth root buttons. Okay? So if on your calculator you have x squared equals 100, how would you solve for x? What would you do? You would square root both sides. Very good, because a square root cancels out a squared. So then x equals what? 10. Good. If I have x to the fourth equals 1, what would I do to both sides to solve for x? Fourth root. Very good. If a square root cancels out a squared, a fourth root will cancel out a 4. Right? So then x equals, what's the fourth root of 1? 1. You guys remember how to do fourth root in your calculator?
Yeah.
Yep. Math. Yeah, you push 4 first, then math, and then this X button, right? And then 1.
And you type out father.
Okay, let's try another one here. So again, if I wanted to solve for X, what would I do to both sides? Square root, very good. And here you'd probably need to use your calculator. X equals what? 0.5. And x to the fourth, what am I going to do to both sides? Fourth root. And this one I put in here because I want you to practice if you have a fraction, right? And you're fourth rooting, you got to have 16 divided by 81 in parentheses. And then go math, enter, enter, and you should get 2/3. You guys get 2/3? So you'd go 4, math, and then that X root button, and then you'd have parentheses 16 divided by 81. Close your parentheses. That means you want the fourth root of that whole thing, and then you should get a decimal, and then you'd go math, enter, enter. Anybody not get 2/3? Okay, good. Okay, so that's kind of how to solve for X. So when we're using these formulas, whoops. All right, so let's look at the first one here. The first formula that we can use is radius for a sphere. Okay, the radius of a spherical balloon can be expressed as r equals cube root 3v over 4 pi. R is the radius, v is the volume. Okay. If air is pumped to inflate the balloon from 500 to 800 cubic inches meaning, what am I talking about there? The radius or volume? The volume. Whenever I'm talking about cubic inches, cubic centimeters, cubic anything, that's always volume. How many inches does the radius increase? So if I go from 500 to 800 cubic, right, the volume, how does the radius increase by? From what to what? Okay. So first thing, these bullets kind of walk through what you need to do. The first thing I need to do is what's the radius of the balloon originally? So when it was 500 cubic inches. So let's look. For 500, I have my formula, right? And I'm going to put 500 in for V, because that's my volume. So R would equal cube root of 3 times 500 over 4 pi. Okay. And it seems simple enough, but the hard part is actually going to be putting that in your calculator correctly. So try putting in your calculator, see if you get the right answer. How I like to do it, since this is a lot of operations going on and students get confused of how many parentheses to do, I like to do just order of operations on the calculator. That's what I suggest if there's a lot of stuff going on. So to do order of operations, I would go 3 times 500, right? And then I'm dividing by 4 pi, 4 times pi. So I'd go divide by parenthesis 4 times, and then we can use 3.14, that's fine. But I have to have parentheses around that because I want it divided by that whole product. And then I can take the cube root of that, math, down to number 4, cube root, and then I can go second negative sign to recall that answer. And I should get 4.92. That was my original radius, 4.92. figure out how much more it increases by, I have to do the same formula, but now instead with 500, I got to do it with the 800. So I can see how much it increased by. So I'm going to have the same formula, cube root 3 times the 800 now, divided by 4 pi. Right? So again, I would do order of operations. I would do 3 times the 800 divided by parenthesis 4 times pi. And then I'm going to cube root that. So math, cube root, second negative sign recalls, and I get 5.76. Okay, we'll agree to round to the, and right, this is labeled inches. So if I wanted to see how much my radius increased by, what am I going to do with these two numbers? Subtract. Very good. Yep. So 5.76 minus 4.92 equals 0.84. So I would say it increased by 0.84 inches. Make sure you have labels on all of these problems today. Voltage V of an audio system speaker can be represented by V equals 4 times the square root of P, where P is the power of the speaker. An engineer wants to design a speaker with 400 watts of power. What will the voltage be? So I'm going to put 400 in for what variable, V or P? P, very good. So volts is going to equal 4 times the square root of 400. What's the square root of 400? 20. Good. So it'd be 80 volts.
That's it?
Boat building. Boat builders share an old rule of thumb for sailboats. The maximum speed K in knots is 1.35 times the square root of the length L in feet of the boat's waterline. A customer is planning to order a sailboat with a maximum speed of 12 knots. How long should the waterline be? Okay. So this problem doesn't give you the formula, it only describes the formula. So the first step, we're going to have to write that formula out, which is going to be what?
K equals 1.35 times the square root of L.
Good. K is 1.35 times the square root of L. Good. Now, if I want it to go 12 knots, 12 is going to go in for what variable? K. Very good. So 12 is going to equal 1.35 square root L. Now, this is something new. How do I solve for L? What am I going to do first?
Or not square root, but like square.
Before, I can't order of operations backwards. So, right, a squared gets rid of a square root, but I can't do that yet. I have to divide by the 1.35 first to isolate that radical, and then I can square both sides. So my first step would be to do this, 1.35, right? So that gets rid of that, which is what?
8.88.
So we'll say 89, okay? So right, to get rid of a square root, I'm going to square both sides. A square and a square root always cancel each other out. So then square 8.89, and what's L? 79.01 feet, right? Feet. Good. Okay. So the second part is how much longer would the water line have to be to achieve a maximum speed of 15
So do we
knots?
just do the same thing except put 15?
Right. So now I'm going to put 15 in for K, and I want to see how much my length has to increase.
Oh, so you do those change things.
Yep. Because when buying boats and making and selling boats, boats are basically, the longer the boat, the more expensive it is. So if you want to jump from 12 to 15 knots, you have to see how much more money is that basically is what you're thinking, because how much longer does my boat need to be? So divide by 1.35. What is that?
11.1111.
So 1, 1. Okay, and then to solve for L, I'm going to square both sides, because the square root and square cancel each other out. So then what's L?
123.45.
So 4, 6.
46, yeah.
Okay, feet, right? But my question is, how much longer would the water line need to be? So what am I going to do with? I'm going to subtract this from this to say how much longer it would have to be, right? So what's 123.46 minus 79?
44.45.
44.45 feet. Good. That's how much longer my boat would have to